Recording. Sweet. Okay, this is OnShape. OnShape, if you're unaware, is a CAD software that is free online. It's been very, very free for a long time, but they're slowly making it less free as it gets good. As it stands, if you're using it for personal purposes, you can still use full-featured version of it, but your documents are public. So anything that you create, other people can see, and then companies pay for it to be able to have private documents. I have private documents on my account because I have an education license that I got literally by just saying I coach this high school team. But you come to the OnShape website, you sign in, you get to, it warns me my password has been used in a leak of passwords. And then you have just your list of documents. This is kind of where you start out and browse. I'm just going to scroll through this briefly. You can see kind of all of the different things that I've designed in OnShape throughout the years. We're going to crack open one of these. I'm looking for long shot. No, not vacuum. Oh, long shot 3-pound. Here it is. It's all the way at the top. This is just an example of like a fairly well done, fairly good OnShape document. This is something I did with 4 friends when we were building 3-pound BattleBots. And we, in CAD, collaboratively designed a series of chassis and a series of weapons that would fit on those chassis that we then took to competition, and they actually fit together. And they actually worked when we were able to put the chassis and weapons together. So we were able to design a modular drive base, and then people designed a bunch of other things on top of it in different documents. This is actually what I'll show you guys a little bit of detail first so you can get some of the flavor of OnShape. This is my design for a horizontal spinner weapon that went on the front of it here. I'm going to briefly just sneak peek the power of OnShape and why I use OnShape, and that is this idea of parametric CAD. Parametric CAD means we don't hard code all of the positions of all of the things in the document. Instead, we build everything as references and math and geometry off of each other so that we can change dimensions and everything updates automatically for us. So when designing this BattleBot, I had a very, very hard 3-pound weight limit. I wanted to make the bot as big, as powerful, and as heavy as I could, up to 3 pounds exactly. Well, I don't know up front how thick the aluminum plate's gonna be, or how long the weapon is going to be, or what. So I wanna make the design with just some major key parameters that let me play with it. And in this design right here, just to show this off a little bit, I have the length of the weapon as 3.75 here. If I go in and I change that to 4.5 and hit enter and give OnShape a minute to think, this whole thing automatically extended out to be that long and everything updated. I do have an interference here where my weapon's now gonna hit, but like a shitload of geometry just automatically recalculated and rebuilt itself off of that variable. That is why you should do CAD. Like if you're doing CAD just to stick geometry in space, you can go use Google SketchUp and you can go use Blender and you can just play around. OnShape is for making designs that you are going to manipulate that design a lot and you want a bunch of geometry to update off of itself. I think good CAD is a lot like computer programming. You are building a set of instructions to make the part that you want. And if you build those instructions right, you have modular, good software that can be reused and adapted in a lot of different ways. So that's just a little bit of the flavor of OnShape. I'm gonna run away from this document now, and we're gonna start with a brand new, fresh document and just build something from scratch. I'm gonna show you live how I build it, and hopefully it works. So, quick little document here. The first concept to kind of get introduced to in OnShape is that OnShape has part studios and assemblies. And when you create a new document, it will by default automatically create one part studio for you and one assembly for you. Part studios always have everything in them having fixed geometry. Nothing is allowed to just freely move in a part studio. But everything in a part studio can reference the geometries of everything else in it. And this means that in one part studio, you can design 5 or 10 parts that are kind of statically set up with each other, and they can all steal dimensions off of each other so that they can figure out where this hole should be based off of like the edge of this other part. but everything in a part studio is static geometry. That's your actual CAD that's generating your parts. You go over to an assembly when you want to make pretty pictures and render things and have things move around. In assemblies, you combine a bunch of parts that you've generated in a part studio together, and you can create things like joints. So generally, in a part studio, you only want one copy of like every unique part in your system, and then in the assembly, you go and put everything together in the ways that you want. This is a little bit different than how like SolidWorks does it, where you just have a part and then assemblies. But part studios are really powerful, and you'll see that here because we can make multiple parts and they can steal geometry from each other. So by default, over here on the left side, oh, and I'm gonna make this full screen so it looks a little better. This features list here is how OnShape is actually going to build the rules that produce your part one by one. And each time you do an operation in OnShape, it will get added to a list here that will slowly grow down, 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 and then you can use this rollback bar to like go back to previous parts in your design and re-edit them. It starts with some default geometry for us of just an origin and some planes, and that's really useful as we do our first step. And our first step is the same thing that you would do basically in any CAD software, which is create a sketch. OnShape has this kind of standard pop-up window that happens anytime you like enter a command for it, and that command needs information. One of the things that I don't love about the UI that's like pretty not obvious is this blue box right now being highlighted, making this select a sketch plane. If I click on any plane in the software right now, it's filling out that box. And that box was auto-selected for us when this dialog opened. So I'm just selecting different planes to sketch on. But we're gonna sketch on the top plane. And this is also something I hate about OnShape. If I click this checkbox, I'm not in the sketch anymore. It has now produced an empty sketch. If I double click back on this, we're now back to editing sketch one. And all of the tools at the top bar have turned into sketch tools here. That's just something, it's gonna confuse the crap out of you when you start using it. Like while this little box is up, you're in sketch mode, and when you click the checkbox, you're done sketching. Annoying, but it works. So I'm gonna click the little top here to focus us, so we're now sketching in a good top-down view. And just to explain the part that I am hoping for us to create, I'm hoping to create a box with a lid, with a hinge in that box, kind of suitable for 3D printing. So it's just gonna be a box and a lid that we could 3D print kind of as one piece, and hopefully they would work together. So to make that happen, I'm gonna start with making a rectangle here, because I'm gonna have some kind of box. And now, immediately, some of these lines are black, and some of these lines are blue. A line in a sketch will be black if it is fully constrained and can't move anymore, and it will be blue if it is under constrained and can't be moved. OnShape automatically generated some constraints for me when I started my box and I clicked the origin. It made this corner of the box attached to the origin. And you can see, as I move my mouse around to different locations, different of these little constraint symbols pop up and appear temporarily. Those are automatic constraints that it put into the geometry for me, like the fact that this line is perpendicular to this line is controlled by this little constraint. When you get good at OnShape and know what's going on, you don't have to think about these constraints too much, and they're pretty automatic. As you're starting out with OnShape, I think it's really useful to check this Show Constraints box that then just makes all of the constraints that exist automatically appear. And so for instance, one of the constraints, coincident here, this coincident constraint is making these two lines end at the same point. I've selected that constraint now, and if I delete it, those 2 points are no longer connected to each other. And if I pop down the little constraints toolbar here, I can grab coincident, I can select this point, I can select that point, and I can recreate that constraint now. There are some chairs up here if you guys want to sneak into some different spots. So what you want when you create designs in OnShape is you do want everything to be black. You do not want to leave anything unconstrained, because that means it can just pop around and like explode suddenly if the design goes awry in some way. You want to constrain all of your geometry. The most common way that you're going to constrain geometry is with the dimension tool. And it is somewhere up in this toolbar. I actually don't know where. Here, I'm gonna click in here and I'm gonna say dimension. Oh, it's right there. I don't know where it is because I hit D on my keyboard every single time. You learn a lot of keyboard shortcuts when you do OnShape. So the very naive thing to do would be to hit dimension. I can select this edge and I can now tell OnShape how long I want this edge of my box to be. You can do a lot of fun things in here. Just to show you, for example, I can do 1 inch plus 5 millimeters divided by 2 times 4. It'll do all that math in there. You can put full equations in there. You can also, when you click back in, the equation that you put in will be present, and you can reuse all that good information. You can also reference other dimensions and you can reference variables in here. That's not actually the dimension I wanted. What I do want, though, is I want a dimension for, I want a variable that I'm going to use throughout the entire application for the width and length of my box, because we want to make those parameters that we're going to vary in our design. We want to reuse them in several places. What I am going to do now is close the sketch temporarily. I'm back in my sort of main window here. I'm going to do the search tools because I never remember where this one is. And I'm going to look for variable. And it's hidden under this pop box of like other things that you can create, but I'm going to create a variable. I said I'm going to create a variable. Little variable thing pops up here. And so you can create variables that are assigned, meaning I am giving this variable a property. You can also create variables that are measured if you want to measure some dimension that is calculated from your model here and have it calculated. But I'm going to name this variable length. And I'm going to set its value to 4 inches. Actual value doesn't matter too much, and if I was really good, I would put a description in there, but I'm not going to. I'm going to create another variable, and I'm going to call it width, and we're going to set it to 5 inches. As well, units matter. You got to have units on stuff, and I'm going to create one extra variable, and I'm going to call this one wall thickness. And we're going to use this one a lot, and I'm going to say 1/8 of an inch. Just as some general dimensions to get us started with. Now, I'm going to show you one of the other confusing parts of OnShape. The way that I use a variable in a sketch is I would go into my sketch, I would create my dimension, and in here I would say hashtag length. And if I do that, it tries to create a variable named length. That's not what we wanted. Why did that happen? Well, if we go over and we look at our left bar over here, we can see that length, width, and wall thickness are grayed out. They are grayed out because they were created after that sketch was created. At the time that they were created, they had access to all of the information that had been created before them, but we now can't use those because they exist in time after the sketch. Hard to explain as you're getting used to it, but as you learn, this system ends up being really, really powerful. So what do we have to do? We have to make those exist before the sketch, and I do that by dragging them above the sketch. And in this case, OnShape lets me because there's actually not any geometry conflict there. But if I had made wall thickness dependent on some dimension from the sketch, and then I tried to reorder them, OnShape would have gone error. This variable can't be moved before this because missing geometry kind of constraint would have happened. But no, and like the thing that I'm really trying to drill home here is that these operations on the left side here are created sequentially in time and have access to whatever existed before them. Make sense? Okay. Now I will actually show using the variable. We're going to have a box drawn in 20 minutes. Good job. So I'm going to use length there. I'm going to go over here and I can use width. And as soon as I type W, it's automatically showing me that those variables create and letting me do nice autocomplete. You know what? No, I'm going to fix it because it's going to bug me. I've decided this is length and this is width because I don't know. I'm picking my own coordinate system. So dang it. Length. Okay. Now, I'm going to make the bottom of our box. I'm going to make our box with the bottom of it sitting on this plane. So the next thing to do is once we have some 2D geometry, we turn 2D geometry in a sketch into 3D geometry with one of these 3D operations up here. And there are a crap load of these, and they do lots of really, really cool things. And if you hover over them, OnShape will explain them to you. I'll be honest, I think 99% of all things that get CAD'd with the extrude operation. There are some cases where these other operations are very useful, and like I do like fillet and chamfer, but most of these don't matter, and extrude is what you should generally think of most of the time. So when I click extrude, extrude has a bunch of options in here to like, I can make a solid, I can make a surface, I can make a thin, don't ask what a thin are, they're weird. I can create new objects, I can add to an existing object. There's a bunch, but we're gonna start with the very basic. We're gonna create a new solid, and then it wants us to select faces or sketch regions to extrude. We click on our box, and it's now showing us a kind of preview of what that extrusion would look like. And I can grab this and drag it around to kind of visually change it. You can see the number for depth updating here, but what I really want to use in depth here is actually a variable, excuse me, and I'm going to set the depth of our extrusion here to the wall thickness. And now that's constrained nicely, and we have the bottom of our box. Great, very simple. Pause for questions.
So can you, never mind, this is 2 minutes.
Okay, sweet, sweet. We're now gonna go back, and this is another thing that I would encourage you guys to do in OnShape. What a lot of people think they want to do in OnShape, and I would consider this like noob OnShape usage, is to create a sketch, do an extrude, then create another sketch, then create another extrude, and have this chain of sketches and extrudes on top of each other. Generally, I don't recommend that. What I recommend is creating one sketch that's like your top-down sketch and putting all of your geometry from that view in that one sketch and then doing a bunch of extrudes off of that one sketch. When you do it that way, you get a lot more use out of the geometry tools. Things are stacked off of each other. I think it makes sense. So most of my like advanced things that I've done, maybe 4 sketches, maybe 5 sketches top, but try to keep your number of sketches down and use a lot of geometry in one sketch. So we're actually gonna go back to our sketch 1 here, and I'm gonna add the next thing that we want to extrude to this sketch. So what I actually want to extrude is I want to extrude the walls of our box that are gonna be coming up from this. How am I gonna do that? Well, I'm gonna draw another rectangle inside of our rectangle, and this bad boy is just floating in space right now. So I want to constrain this rectangle to be the walls of our different things. So the first thing I'm going to do is I'm just going to add one dimension here, and I'm going to say hashtag wall thickness. And that made this gap between these two, that 1/8 of an inch that we set as our wall thickness. That's not too crazy. Now, if you were a noob in OnShape and you were doing things the basic way, you would now repeat that dimension 4 times on each side and have a bunch of wall thicknesses repeated everywhere. That is valid, that is fine, you can do that, but I'm trying to teach you how to do things a little better and to not repeat yourself a lot, and we can actually constrain this sketch nicer with fewer operations. And I'm going to show you one of my favorite tricks to do that. And the first thing I'm going to do is I'm going to create a line. So I hit L, this is the line tool here, I'm just going to draw a line, and I'm going to slide my cursor along this line until the symbol for the constraint changes. And you see how it's showing me coincident, 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 and then it changes to that symbol? That symbol is the midpoint symbol, and so this line is going to end up constrained to the midpoint of that, and I can go over here and it'll snap to the midpoint again. So now I have a line that is already black because it's already tied to the midpoints on both of these guys. I'm now going to select this line and I'm going to hit Q on that line, and that turns it into a construction line. What construction lines are lines that you can use to reference geometry and create constraints, but which actually aren't going to be available for extrudes. So one of the things I'll show you right now is like, when I hover my cursor in this gray area, it is currently highlighting this entire box that goes around, which if I tried to select this region in OnShape, it would extrude this entire box that's kind of there. If I go and I turn this back into a solid line, when I hover over here, it's now showing this kind of implicitly created smaller box. Does that make sense? So construction lines are fake lines. Like they're lines that you can use, but they don't actually have to exist. So now I'm going to go and I'm going to create another line. It's over here. I'm going to find the midpoint if it lets me. Yep, there's the midpoint, and I'm going to go over here and find the midpoint, and I'm going to make it a construction line. Now I have 2 lines that are crossing the symmetrical axis of my box. I'm now going to go into the constraints up here, and I'm going to grab the symmetric constraint. And this is kind of a weird one to use. Like, there are 3 things involved in a symmetry: the A thing, the B thing, and the thing that they're symmetric about. And the pattern you click in OnShape is one of the things you want to make symmetric, another thing you want to make it symmetric, and the line you want to make it symmetric about. And that now made this part snap to the other side automatically. And now if I wanted, I could, here I'm gonna delete this dimension for a second, but you can see now as I drag this point around, how that other side is now moving symmetrically with it against the other side. That's cool, that's nice. I'm gonna make the other side symmetric, this and this symmetric about this line, add this dimension back in as wall thickness. And honestly, if I was writing this myself here, I would also make this dimension wall thickness, but because this is a tutorial and I'm trying to show you stuff, I'm going to do one more slightly dumb thing, but it's a cool way to show it. So I'm going to make another line here that's actually going to run from the corner of my part to the center. I'm going to make that a construction line, and I'm going to say I want this corner to be coincident with this. I do that by going up here, grabbing coincident. I'd like this on that line. That's one way I could do it. That's not actually technically correct because this angle isn't 45 degrees, but it would work. You shouldn't do that. I realize that's a bad idea. I'm undoing it. I showed you how to do it though, which is the important part. So I'm going to make this wall thickness. I'm going to repeat like that. There. There's our one sketch. So we hit done on that sketch and a bad thing happened. What bad thing happened? Our extrude that we had previously done is now messed up. Why is our extrude messed up? Because it doesn't know how to independently identify which of the regions in our sketch we tried to select earlier. We just selected some square, and where there was one square previously, there's now 2 squares. It doesn't know, should I use both of them? Should I use one of them? Should I use the other one? It did a dumb thing and picked just the outside edge of one. That's not an incredibly dumb thing, but it works. So I've now gone in, I now selected both of those sketches to undo the kind of oddity there. And yeah, we're gonna say done there. Sweet. I'm gonna make one more variable while I'm here. Variable. Thank you. I'm gonna name it height. Realized we didn't make height yet. And I'm gonna say 3 inches. And I'm gonna drag height up here so I can use it and have all my variables at the top. And now I'm just gonna do one more extrude operation by hitting extrude here. So we have a problem, and that's we can't actually select our sketch anymore. Where'd our sketch go? OnShape decided that the right thing to do, and I disagree with this highly, but when I used this sketch in this extrusion, it automatically hid this sketch and grayed it out. And so now you have to click this little eye symbol where that eye symbol doesn't exist until you hover over it. So good luck finding it if you didn't know it was there, but now I can click that little symbol. Now our sketch shows back up and we can select it. Note, I'm rotating to the bottom here because if I try to select here, I'm selecting the top side of the shape we already extruded and I can't kind of click through to that sketch. So I'm coming around to the bottom and I'm grabbing our outer wall shape now. And I'm going to extrude this. How far do I extrude this?
2 inches?
So if I did height, we wouldn't leave any space for our lid.
Yeah.
And if we want height to actually be the outside dimension of our box, we want to leave space for the lid. So how can I do that? I want to extrude height minus wall thickness. Look at that. It does all the math for me. And I can change wall thickness and it'll automatically adapt. Cool. Like that. Love that. Look, guys, we got a box. We got a box. That's great. Okay. Let's add hinges to this, and then we might do our lid at the same time. We'll see how we go. So I'm coming around to the left side now. If I want to make the lid and I want to kind of like make some hinge geometry over here, I can't really do that from the perspective of the top-down view. So now I'm going to make us a sketch on the right side here. And I could make this sketch purely not referencing any of the geometry we've already created, because I know what the dimensions are from my variables over here, but I'm going to show you guys how to reference geometry because it's really, really useful. So right now this sketch doesn't have anything in it, but there's this really, really, really useful tool called Use Project Convert, which lets me go around and click on anything that's in the 3D model, and it will project that into the 2D plane that we're sketching in. So if I click this just outside box right here, it makes in the sketch, those lines turn black. I now have sketch geometry for where all of those edges of the box are in this sketch. I can also go in and I can click on the bottom here, and it creates this line for me, which is the 2D projection of the bottom of our box that shows me where the inside corners are, if I needed those things. We don't super need those, but we're gonna build off of this corner over here for our hinge and our lid, and that'll be nice. And so I'm making up what I think I want my hinge to look like here. So I know there's gonna wanna be some kind of rotary joint, and I know that if I keep the rotary joint in line with this point, then the lid will close perfectly. Like there will be no weird gap with the hinge being misaligned. So I'm gonna start here, and I'm gonna drag to the side. I'm gonna create our little circle, and our circle, by starting there and dragging to the left, ended up constrained to that line automatically for me. One of the things that you will absolutely hate about OnShape as you go to learn it is that it automatically creates a lot of constraints for you depending on like mouse stuff that you do along the way. So like if I'm just in space right here, I can create a point and there's no constraints to it, but as soon as I start touching stuff, it starts like trying to make automatic constraints. And it's showing me a preview of the automatic constraints it's trying to make as I move this around. But you'll make something and you'll be like, why won't it let me move this? It's because it put in automatic constraints for you. But let's call that the pin of our hinge. And I'm gonna say the pin of our hinge, just eyeballing it, let's say 1/4 of an inch for the hinge. Yeah, that seems pretty good. I'm gonna make another circle around that then, and I'm gonna make it a little bigger, and I'm going to put in a tolerance as a gap for how much clearance the hinge should have to be able to move. Just, you know, like 3D printer tolerances, how much free space do I need between the pin and the hinge body? I'm gonna say 50 thousandths of an inch, just so that there's a little gap there for some clearance. I'm gonna make a line now, because I'm kind of imagining like this hinge has to be somewhere in space. I need something that's gonna hold it. I'm just improvising. Yeah, something about like that, doing a little free form. Well, something like that, maybe, yeah. And then let's do a arc. Yeah, I'm gonna do a 3-point arc, and I'm gonna connect these 2 points. Kind of go like that. Yeah, now we kind of got some structure that would hold the hinge. I'm gonna use my coincident tool, and I'm gonna make this point coincident to that point so that the like radius around here matches that curvature. I don't like that there's a little kink there. Like that kink looks ugly to me, so I'm gonna make that kink go away by grabbing the tangent tool and making this line tangent to that arc, and that forces those to be smooth. I'm gonna make the other side tangent as well. And now I kind of have just some rough geometry here with some constraints on it, and so I can kind of drag this around and see how it's unconstrained and different facets of how it looks to kind of get an idea of what I want it to look like. So one thing I'm thinking about constraining here is like I need enough meat on this hinge for this outer part to be strong enough to actually support the forces. So going in here and dimensioning the gap between those two spaces, I can say, we need a decent amount of meat there. How about wall thickness? Why not? Reuse the variable. Yeah, that seems about right. That's about how sturdy that'll be. We have to pick some kind of distance here for how far away we want this from the edge. I think aesthetically pleasing, making this a 45-degree angle kind of seems like a cool way of doing it. Yeah. So what's 90 degrees plus 45 degrees? Because I can't do that math in my head. I should know that. I should know 135, but tell you what, I don't have to when I use a calculator. And then finally, like the only thing that's left, whoa, that's, it's funny, like I've not seen it do that before. It's like struggling to solve as I move, but it eventually gets, anyway. The only kind of last thing we have is just this position is the only thing left to constrain. I think we'll just stick a dimension there. Oh, look how close to an inch that is. Just aesthetically, that looks like it could be a nice hinge. We'll start with that. We'll do an extrusion to begin with. We'll extrude this outer profile, and that's kind of going to make the outside part of our hinge. We'll extrude some distance in. We're going to call that wall thickness. Great. Very nice. I have the outer part of my, ooh, actually, never mind. I don't like wall thickness. I decided that's bad. Also, just pro tip, please don't be like me. If you're working on a serious design that you're going to spend any time on, please, dear God, go in and name these. Like you will thank me later when you're dealing with extrude 114. Please, seriously name these. But going back in and editing hinge tab, let's say 4 times wall thickness. I think that's closer. Yeah, that looks sturdy. That's not going to snap off. Okay, but I also want this hinge on the other side over here, right? We could put it on that side by doing another extrude operation, and then we have to figure out where this edge is and extrude back the other distance. That is one thing that we could do. Another thing that we can do is take advantage of the fact that our design is symmetric and use a different one of these 3D operations. To do that, the first thing that I'm going to need to do is to create a new plane. And I'm going to create a plane as a mid-plane between 2 entities. I'm going to select this face. I'm going to select that face. OnShape's going to create a new plane there in the middle for us. Boom. I can now call this mid-plane. And I have now a convenient place to operate at the center of my design. I intentionally sketched this with the corner as the center to just, like, there's no right or wrong way in CAD. There's different options. But if I want to take advantage of symmetry here, I'm going to use that plane. So now there is this wonderful, wonderful mirror button here. And mirror will let you mirror all kinds of things, including mirroring whole parts and mirroring entities. But the thing that I want, ooh, am I actually using the right? Oh, sorry, I have to open up the little drop down here and select feature mirror. That's what I want to do. And then features to mirror, I can click on this. It will automatically figure out what geometry is attached to it. It asks for what mirror plane to mirror about. I can select this, and boom, it put the hinge on the other side for us automatically, and that will auto update. This is the power of OnShape, is when you build things with the right constraints, your design can auto update in really, really, really powerful ways, and that's very, very nice. So time to make our lid. Let's go back to Sketch 2 now, and I'm going to double click into Sketch 2, and you'll see when I click into Sketch 2, both of those tabs disappeared. They do not exist at the point in time that we drew Sketch 2, so we can't use them in Sketch 2. And now we just got to rough out some geometry for our lid. So the way I'm going to do that, we got to make a box here, like that. I'm going to use coincident. Sorry, I'm going to try to press less keyboard shortcuts because I just do them automatically. I'm going to try to show you guys where I'm clicking, but I know a lot of keyboard shortcuts at this point. Wall thickness, that's kind of what our thing looks like. And now somehow we have to figure out a way to smear that over to that pin. And I'm going to do that however I feel like. What floats my boat today? We're going to do a line. We're going to do a line. Oh, this is going to look real funky. Oh, well, whatever. Some guy on Thingiverse will make fun of me later. Let's make this tangent to that. And there, that's fully constrained. Just 2 straight lines from the edge touching the circle there. This will be a little weird knew that was going to happen. In hindsight, like if I was doing this well, I would actually probably make these 2 sketches because this like overlapping geometry in this one sketch will cause all of our extrudes to be a little funky. But no going backsies when you're doing it live. Going back into our hinge extrude, I'm going back into the faces to select. We just have to reselect that region. That's back to go. And now I can do one more extrude for our lid. We're going to grab, we have to turn our sketch back on so we can see it. We'll grab the pin, we'll grab this part, this part, this part, and this part. Oh wait, we can't do all of those. What's going on? Oh, it's because they're going to collide with each other. It's mad about us. So we don't want to extrude all of that yet. We're going to do this in a couple operations. So I'm going to start with extruding the lid all the way across. Then we'll extrude some part in the center that's going to clear these hinges. And then we'll come back and we'll do the extrusion with the pins. It'll make sense when I actually do this. So right now, you see how this is blue? This is blue because OnShape figured out that like this extrusion is touching this part that already exists, and it defaulted the extrude to add as the type here. It's going to make these one physical part right now. But if I just go over here and I click new, the color changes because this is now going to be a new part. It's going to be distinct from the previous part, and we can see down here in our little like parts view, there's part 1 and there's part 2 showing up now. So how far do we want to extrude this? Well, one option that we could do here is we could use either length or width like that. I don't know, it's one of the two of them. I probably got it wrong. I did get it wrong. Well, there's a better way. There's options here. Right now, the type of specification of distance to extrude that we're using is blind. I'm actually going to change that, and I'm going to change it to up to face. And then I'm going to slide on over here, and I'm going to click this face, and it's going to extrude up to that face. Boom, beautiful, nice. We hit done. We now have the start of our lid. I'm going to be a good little engineer, and I'm going to go over here, and I'm going to click rename, and I'm going to say lid, and I'm going to click on this part, and I'm going to say bottom. I don't know, maybe box. Bottom's fine. Okay, so now we have some more geometry to add to lid to actually make these pins kind of connect to the lid in some way. So we're going to do some more extrudes, and it's going to get wild. So we want to extrude this part, and this part, and we want them to be between this part and between that part. So we're now going to change our extrusion operation here to second end position, which means that we're extruding in two directions right now, and I can show you that we're extruding here, and right now it started that extrusion pointing the other way. If I click this opposite direction arrow, it's going to flip around, and now you can see that extrusion kind of floating there in the middle between those two things. Right? Make sense? Now we can select the position of this one to be up to face, and I can click on this face, and I can select the position of this one to be up to face, and I can select that face, and now we've got it running right there. That is technically wrong. I would not do it that way because we didn't leave any tolerance room, and that'll be a really stiff hinge, but whatever, this is an example. It's also right now showing up in dark blue here because OnShape went back to new over here for some reason. I want to change that to add. Why is it mad now? This extrusion shape is simultaneously touching the bottom and touching the lid, and it doesn't know which of those two parts we're trying to add to. So we have to specify a merge scope down here, and I'm going to click on lid, and now it knows that we're adding this geometry to the lid, and it's created that part. Oh, what did I just click? Oh, I clicked on thin. Shouldn't have clicked on thin. Checkbox there. Sweet. We've got that part. One last extrusion to make our lid complete. And that is going and grabbing this little pinny section here. And we just need to do up to face. Click over there. Pin now goes all the way through. Boom. Right? Right? Everything looks good?
Is the lid attached to the pin?
Is the lid attached to the pin? Yes. It just like OnShape will do a lot of things for you automatically. It automatically realized that was touching the lid, it set it to add, and it merged with lid, so it all ended up gray, and I don't have some third part sticking up over here. Just to show if I'd done that wrong, if this was new instead of add, we would have ended up with part 3, and OnShape would have made it blue because it'll automatically make each new part a new color to kind of show you, hey, these things aren't connected, but I can go back to extrude 5, I can say add, it figured out lid automatically for me, boom, there's our thingy. So, we could do a lot of extra adjustments on this box for like making the model better, but I'm actually going to take a pause from modeling here to go show you. You're okay. That was terrifying. To show you the assembly side of things. So like right now, like I can't drag and click any of this, like all of this geometry is fixed, but we can go over to our assembly now, and our assembly has nothing in it at the moment. Like it's just a blank, infinite void. I feel like some physics teacher in high school is just really excited right now, but to do anything interesting into an assembly, we have to insert something into it. And it's automatically showing right now, Part Studio 1, bottom and lid. That's cool, that's fine. One of the superpowers of OnShape and why I use it for an enormous amount of stuff is this Other Documents tab. What is this? Oh, this is everything anyone has ever modeled on OnShape under a free account and made public. And I can go over here and I can say like human, and here's a bunch of different people's models of dudes that they've created, and I can click on one of those and I can grab their whole human model and insert it into my assembly. I can also insert their human model into my part studio and then pull dimensions off of it and make my part perfectly fit this human. This human's also really nicely rigged with mate features on it, like all these little like coordinate system things that it's showing are convenient ways to have this human automatically attached to like handles or things. You can make configurable assemblies that have like automatic mating parts on that if I wanted to put a wrench in that dude's hand. But there's a person. I actually really like putting a person in a lot of my assemblies for scale. So, oh, oops, his body's not attached. We'll fix that. But while I'm in here, I'm gonna go back to current document. I'm gonna click on Part Studio, and there's our little box in perspective with the human. So clicking done, I'm done with adding. You can see now all of the things that it added, and it added them all as independent objects. Right now, everything is totally free of each other and floating around. So the first thing I'm gonna do is I'm gonna grab all of the human, and I'm gonna go to the group thing here, and I'm gonna say that's a group, and I'm gonna group all those together, and now they're all just rigidly attached to each other because I don't wanna make that human opposable, but he's kind of creepy, so let's grab him, let's rotate him so he's looking there, and let's just slide him off into the distance and forget he's there until he surprises us. Okay, back to the box.
Can you put a garage door?
I'm moving these around just so that they're a little closer to the origin, and I'm gonna use the origin here. All of these are different mates that exist, and mates are just like OnShape's name for a joint. Fastened mate is how you rigidly attach two things together. So if I want to glue two things together, I use a fastened mate.
So like that part is logically separate from the bottom of the box, right?
Yes.
How does it work with the sketch? Because your sketch is still positioned with the box, I assume, right?
Yes. The sketch creates two parts.
Yeah.
The positions of those parts disappear when those parts are pulled into assemblies. And if I move them around in the sketch, those positions don't matter anymore.
I got it. So you would back up in your timeline and change something. But
Yep.
when you did that, those are still mated, and then it would just apply whatever changes happen.
Yes.
Okay.
Yep. And like crazy thing that happens with OnShape, as I added that dude's human in, I'm actually versioned from this other document. OnShape has an absolutely ludicrous good version management system. We haven't gotten into this yet, but there's an entire Git branching workflow to like branch versions of model, merge versions of models back together, choose what parts of your models are updating from other parts of models so that like I can pull a part into my assembly directly, like fully linked, or I can pull a version of that part from a point in time to my assembly. If you don't look at this, there's like release candidates and like, holy crap, if you used Git for software development, you love OnShape, and like mechanical engineers don't know what they're missing, but sorry, that was a bit of a tangent, but yes. Fastened mate, first thing I'm gonna do, I'm gonna grab the bottom of our box. It automatically is creating these little kind of mate indicators for me to show how it's gonna try to make this thing, and they'll pop around in all kinds of like different orientations as I spin around. I'm gonna grab the bottom of the box in the center, and I'm gonna click origin here, and my camera's being mad at me, but I'm gonna click origin here, and it attached to the bottom of the box to that. Now, there are different ways that it would have been possible for those two things to connect together, so there are options here to like spin that mate around or flip that mate around if I cared to, but I liked how it came out there, so I can say done, and now our box is rigidly attached to space. I'm trying to like click and drag it around. It does not move. Oh wait, I have to, yeah, it does not move anymore, unlike our lid, which I can grab and move around freely, willy-nilly. So now we want to make our lid actually rotate in that hinge. To do that, it's one of these guys. Which one do we think it is? How about a cylindrical mate? That looks pretty good. Allows translation and rotation about the z-axis. I don't like, oh, sorry, right here, Revolute Mate. That's what we want. Allows rotation only. Perfect. I'm gonna go to the end of the pin here. I'm gonna stick it right there. I'm gonna slide over to this. I'm just gonna kind of hover in space here and it will automatically find that edge for me. Boom, there, done, click. They're constrained to each other. That easily, and they can now manipulate and move. There are a lot of cool things you can do in assemblies, which with like simulation connections for stress, when you do stress modeling in it, you can also do all kinds of animations in OnShape that I honestly am not gonna show because I don't really know how to do them. But you can get its like flap this lid for you if you want to make a cool like blow apart thing. And there are some actual real advantages to that because you can do like kinematic studies for like, is there a configuration of joint positions in which these things will collide? It'll let you do that. And one of the things we can go in, we can open up this Revolute joint and I can go in and I can plug in limits here and tell it maximum and minimum degrees of rotation that are allowed to prevent what it lets me do right now, which is that. Like OnShape is not going to be collision aware by default. It will let things intersect, but you can ask it if any things are intersecting to check when you're actually doing designs. So very nice, very good. We're gonna go back to our part studio, and before we make our box more fancy, I'm gonna show off a couple other very useful features of OnShape. One of which is, I'm gonna select our box over here, I'm gonna right click on it, and I'm gonna say assign material. OnShape pops up this nice little OnShape material library, which has almost every material you would care about already in it. But if you want to, you can do custom materials, but I'm gonna click this little drop down and I'm gonna say ABS plastic because I'm gonna 3D print this on the 3D printer. It automatically pulls in all of the stress, strength, and density information for that box. I'm gonna do the same thing for the lid. I'm gonna assign a material to the lid and I'm gonna say ABS plastic again. That's great. I can now click on, I'm gonna go over here, I'm gonna select the lid, I'm gonna select the bottom, and I'm gonna move my head so you can see. Did my head move? Wow, I'm good at OBS. There's this nice little pair of scales in the corner here, display mass properties, click on that. This thing is going to weigh 0.45 of a pound, and it will tell me exactly where the center of mass is and the mass moments of inertia if I needed to spin this thing with a robot and needed to know exactly how the mass is distributed inside it. And if I want to, I can deselect the bottom and get just the mass information for the lid. The lid will weigh 0.113 of a pound. That's just like, CAD is very nice when you can ask those questions and get those questions conveniently answered for you. Any other fun things to show before we make the box fancy? No, I think that's good. Does anybody have questions at this point or anything that you guys would like to particularly see? Otherwise, what I'm gonna do is just keep detailing this box and make it interesting.
No, you mentioned about the tolerance. Would you add it as a new variable, something like that?
Yeah, so I do have, if I actually go back to some of my previous designs, I will show you, I have designs with the tolerance variable in and I reuse that tolerance variable a lot. The reality is, unless you're 3D printing, in the real world, almost every part will have a different tolerance in every dimension for reasons that are like why mechanical engineers have degrees of threads should have this much tolerance, two concentric holes should have these much tolerance, and you learn that. There's not a great lesson to it, but you could definitely make tolerances good. Tolerances as variables is a very good way of doing it when you can.
3D printing is also like that in some ways because if you print across different axes, the tolerance is different.
Totally fair. Yep. So there's not a.
It's definitely easier.
Yep. Yep. One thing I will show. This is just a cool. Sorry. Other questions? Good. Sweet. Other things just to show because this is nice. Right-clicking here, edit appearance is also a very nice thing kind of hidden in this menu, and I can make my part all kinds of pretty colors that I want to. You can also make parts semi-transparent, which is really, really useful when in the CAD. Making them transparent here with the alpha slider, very, very, very useful. And then tessellation quality, if you have crazy models, like it's trying to render this thing with triangles at the end of the day, because that's how all rendering works. If you have models that are getting slow, turning this down can improve things. And then there's like your classic color mixer. So we made our lid pretty blue, make your models attractive. Nice thing to do. You can see there's a lot of things floating around in the background right now because I haven't hidden our sketches, but if I hide our sketches and I hide this mirror plane. Oh, will you let me hide the plane? Oh, it won't let me hide the plane. How dare they? Also, just as another collaboration thing, I'm just pointing out features I can see at the moment. One really, really nice thing that OnShape has when you're working with other people is you can add comments. You can add comments to operations, so there is a way to document. There's also a note feature in Sketches to let you add notes to Sketches. Oh, I am going to go show a different thing, actually, at this moment, which is I'm going to show creating a drawing in OnShape, and this is particularly for these high school kids because I want them to make drawings this year. But when you are an engineer, typically, like if you're just doing CNC or you're just doing 3D printing, you stop at the 3D model and you send the 3D model to the machine to get it made. In the real world, that doesn't happen for dumb, horrible legacy reasons. Instead, you always send drawings. And the drawing includes more information than the actual model of the part does for reasons, but that's where you put a bunch of tolerance and manufacturing specifications and paint color and blah, 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 blah. The world operates on drawings. OnShape has a very good system for making drawings. So down here in the project, I can do insert new tab. These are all of the things that you can create in OnShape besides part studios and assemblies. Variable studios, I've not played with a lot, but let you create like combinations of variables and variables driven off of each other. It's really designed around the use case of like, I'm a manufacturer and I'm gonna make 45 versions of the same part. And you can create like matrices of do every combination of this version of this variable and this version of the variable and make models of all of those for me. It'll do some very cool stuff. There's also feature studios. One of the crazy things that OnShape has, where can I actually find it? Yeah. You can code OnShape in a programming language for it, and people code crazy things in it, and there are certain things in OnShape you shouldn't model, but there are these feature script plugins that you can use to do it. One of those is this belt plugin. So you can have OnShape automatically generate a belt routing for you with this belt plugin where you just make a bunch of cylinders, you click the cylinders and it will route the belt around them and generate that shape of that belt for you. There are also generators like that for gears and all kinds of different things. But you can also go into add custom features here and you can find all of these different programming examples for how you can use a programming language to actually code generation of features in OnShape. That's a cool thing to know it exists. But what we came in here for was creating a drawing. Has a bunch of drawing templates here. If you're working in America, you're probably going to use the ANSI inch template, and it's going to create a new blank drawing for us. This is just how engineers communicate with each other. We're going to say bottom is the part that this particular drawing is going to show. I'm going to click here. It's going to give me one view of it. I'm going to click here. It's going to give me a top view of it. I'm going to click here, drag to the right. It's going to give me a side view of it. I'm going to click here. I'm going to drag diagonally. It's going to give me the 3-view drawing of it. And now I can come around and I can add dimensions to it. Those will be driven. And then I can come in here and I can change their tolerance and change their units and change all of these wild things that engineers use to communicate with each other about how drawings are done. Nothing about this is really important, but just know, like, if you're going to go make a part physically, really nice to make a drawing of that part and then take a physical copy of the drawing with you and try, instead of trying to spin the CAD model around as you're using the saw to figure out what's going on. So minor tangent there. Final thing that we're going to do, we're going to go back into our part studio and we're just going to make this box fancy in a bunch of different ways to show off some features. So the lid's kind of in the way at the moment because I want to do stuff to the inside of the box, and the thing I want to do to the inside of the box are fillets. If you don't know what fillets are, fillets let me click on an edge and it turns that edge into a wonderfully smooth radius. That's a nice blended corner. That alone wouldn't be very fancy, but if I click on this edge and I click on this edge, then it makes a really fancy 3D blended surface at that corner. And just going in here and clicking all these fillets, very, very nice, lets me do cool things. Now, what I would say, one of the things that I hate is fillets in CAD, because fillets in CAD are the thing that break the most when you go back and change other things. Like, I'm going through and I'm selecting all these individual little lines. If I go and make a little kink in the box, the fillets will break. One of the ways that I keep myself from having to deal with clicking hell, of re-clicking a bunch of edges to make the fillets look good, is by not doing the fillets on the full model of the part. But for this particular part, this part is not only symmetric about this plane, but it's symmetric a lot of the ways about this plane. I would have done the fillets on just 1/4 of it and then symmetric mirrored them both times, so I just have less edges to click. The earlier I do the fillets before I do a bunch of mirroring stuff, the more they'll generalize and the less hell I have to click when I go in here and just click everything. And like I can click this entire face and it'll grab all 4 edges, but I don't want that edge. And it's annoying in OnShape, like unselect that edge. OnShape, no, you're drunk. No, please, why'd you do that? Yeah, it's hard to unselect edges in OnShape, so it often is just easier to go around and click all the edges yourself. And like selection and like any CAD software, it's just hard. You get really good at navigating it eventually, but I think I've got all the outside edges I care about. Oh, well, let's get this edge. Yeah. Oh, is that gonna go? Yeah, ooh. Let's do that edge. Isn't that good? Ooh, yeah. We don't want to do the inside here because that's a bit, but ooh, that's a little gross. We're going to ignore that for a second. We're going to come back. We might fix that one. But we can grab this edge. Yep. And done. Well, actually, you know what? Bigger fillets are better fillets. Let's go to 0.2. Yeah, look at how 3D printery that part looks now. Nice. And you know what? We can justify it because these corners are going to be stronger. It's really, really true. Okay, so that's fillets. They're a nice thing. They're a good thing to know. Other thing that we're going to do is we're going to engrave some text on the top of this, which is something that a lot of people want to do. We're going to do that in a new sketch. We're going to slap that down. We're going to use OnShape's text tool, which is functional. It's not as good as a lot of other things. So I slapped a box down there, and I'm going to say Carter's, and highly recommend not doing multiple lines in one text thing. I'm going to do each line as a separate box because then I can constrain them on the actual page. And I'm going to do another one here, and I'm going to draw a similar box, and I'm going to say Carter's cool box. Man, the dudes on Thingiverse are going to love this. So now I have these boxes floating around, but the text just scales wildly. I picked a stencil font here. I'm not sure I actually want the stencil font, but we want to constrain this text so that it fits nicely on the lid of the box, and we do that with our regular drawing constraints using the outside edges of it. So I'm going to use project convert here, and I'm going to click on our midplane. I'm going to click on it. Come on, midplane. Oh, come on. Come on. Oh, it won't let me use the midplane in a project convert. Darn, fine, whatever. We're going to project convert this, and then we're going to draw our midline the manual way to that way. Oh, why is it blue? Okay, that scared me that it was blue for a second. There. We're going to grab symmetric. You've seen these tricks before. Outside edge thing we want it symmetric about. Boom, outside edge, thing we want it symmetric about. We want to make the lines a good size. So what I'm actually going to do is I'm going to grab this edge. I'm manually dragging that to this side before I add a dimension. And let me undo that and show you guys why. If I try to dimension this point to this edge right now, dimensions always have positive value, and that means it gets dimensioned on that side of it. And you can't put minus 0.25 in there. OnShape doesn't let you do that, and almost no CAD software does. I want to get it on this side first, and then I want to say hashtag wall thickness, because reuse variables. Very, very nice. Very, very nice. We'll do the same thing over here, although it's going to be, my text is going to be different sizes. I'm okay with that because it's going to fit to the edges really well, but Coolbox is technically a little smaller. For our line spacing, I'm going to do this to be 0.121, let's say 1. We'll do it like that. We'll do this here, and I'm going to say 0.25. Not perfectly constrained, not getting everything exactly right, but it's there in a nice way. And now the easiest thing to do here is actually the extrude operation. Like there is no like really good emboss. There are some other ways that we could inset this text in, but I'm going to do just a plain old extrude. To save myself a lot of time clicking all these little things, I can actually click the entire sketch. And that didn't work. And I'm going to show you why. And that's because when I clicked the project geometry to grab these outside edges, it made a whole container around the thing. I'm going to click this edge. I'm going to turn that edge into a construction edge. And now it's not a closed area around it. And when I go back to my extrude operation and select the sketch, it should just grab the text this time. Yes. So we could make the text stick out like that, which honestly, like, that would be pretty cool. But let's instead of doing an additive operation, let's do our first remove operation. And we're going to cut the text out of the lid. So the text is going to go down into it. We're not going to go all the way through, although that would actually be pretty cool, but I don't want my stuff to fall out. And so I'm going to say wall thickness divided by 2. We're going to go halfway through the thickness of the lid, just like that. And we're going to do one last really cool thing here that I love doing, which is terribly named, but super interesting, and this is called draft. What is draft? Draft comes from mold making, where if I want to cast something in a mold and I want to be able to pull it out of the mold at the end, I can't have perfectly straight walls. I have to have what is called draft angle so that the part can slide out without scraping along the edges. So when I add draft, it's going to taper my extrusion by that amount, so the bottom of the shape will be slightly smaller than what we started with. I'm going to do a crazy draft angle here of 45 degrees and see if it lets me. We'll see if I can get away with it. Yeah. No, it got mad. I thought I was going to do it for a second. It decided that was a bridge too far. Let's try 20 degrees of draft. And the problem with drafting too much is eventually, like, some of these shapes will cease to exist if you draft them too much. It's thinking, are you going to let me? Yes. And it's at 20 degrees. Oh, wait, it did it backwards. Oh, it undercut them. That's cool. Okay, not what I wanted, but good to know. How do I flip that around? Opposite direction? Yeah, okay. Yeah, look at that. Isn't that beautiful? That's very nice. Yeah, that's Carter's cool box. We're at 7:08, so I finished a little early for kind of like planned material that I had for you guys. I will answer any questions about OnShape or just keep doing random things for the next 10 minutes if you guys want me to. Otherwise, that's class. Shane.
What kind of formats can you export this as?
Awesome question. So the best way to export, select the parts, right click, export, nice menu in here. You get these. Parasolid, Step, IGUS, SolidWorks, Rhino, Obj, STL. I will say 99% of everything I do is with Step. Step is just a good binary format that gets the geometry right, unlike STL where it tessellates it. So Step is usually what I export as to pull into like Fusion 360 or other things. All of these, if you like pick different ones, this menu will change and add a bunch of format options for whatever that export is, but you can export individual shapes, you can export assemblies, you can export in a bunch of different formats. Good question.
So if you have like an image file and you wanted to use that as an object, you just like import. Is that a thing it does?
What do you mean use it as a?
So like for example, if you had an image that if you have like a yeah, exactly. I figured that's the way to go.
I've not done it before.
Like if you have a logo or something you want to put on a box.
Yeah, you can do
Yeah.
that in Fusion. What do they call it?
I imagine it's got just like an import button and then you
Yeah.
So-
ping
Or
generate
just-
PMP, great.
Yep. Yep. Yep.
That's the job done.
This or something?
So I don't think it has a vector option for it. I don't think you can get 3D geometry
That's my follow.
from the 2D thing that you import. So I don't think you can import an SVG and then produce 3D geometry off of it, but you can import PNGs, JPEGs, and bitmaps and like have them be in there. Yeah. So
That's helpful.
Yeah.
Like in Fusion, generally, I'll do that to be able to get the right shape.
Yeah, so you can go
Use it as a
off
guide.
that.
I think you're
Yeah.
still making the sketch, but
Okay.
you can look at it and say, you know, this is the shape, this is the
It's
angle.
like a tiny
Exactly.
Yeah.
Yep.
You can use a grayscale image in Blender to create a 3D shape. You can probably export
Oh, got it.
yeah, so there are options for that. One of the things I will point out is OnShape has what I would consider kind of best in class documentation. This is what the documentation for OnShape looks like. And not only are things like easily searchable and well found, but OnShape has an enormous amount of well produced video examples walking you through like every step on it. I have now taught like 6 years of high school students OnShape. You don't have to teach people a lot. Like the basics that I've given you are enough now that honestly you can go and Google just about anything in the tool. The other thing, like I was implicitly using the search for tool feature around here. Like do not feel like use this all the time. This will let you find whatever you want to do in here. Image didn't show up in that thing, and the only reason it didn't is that I needed to open a sketch first, and then if I'd searched image, it would have pulled up this little dialog for me and let me do all the fun, fancy stuff there. Yeah. Other question?
Does it have simulations, like physical simulations or something like that?
Yes, I would not recommend using them.
Because it's in the browser.
Yeah, and I think they're not baked enough for even like great use. If you want to learn a simulation software, I recommend designing the shape in OnShape, exporting it into a purpose-built simulation software and using those. Because I think like it's not worth investing in learning OnShapes because it's not at the level of quality you can get for free in other places.
Yeah, I can't even do simulations in SolidWorks. Plus it's a browser software.
Yeah, OnShape is working on that. They're going to get there. There are like other plugins that you can do for OnShape where I haven't done some of these in a while. I tried for a while to get a cam in OnShape to like generate toolpaths for it, and there's like plugins that you can add from the OnShape ecosystem to like add features to OnShape that people write. I've messed around with a couple of those. Did not honestly have a great experience. Like would not recommend those. Where does OnShape shine? Relatively simple parts, relatively simple assemblies, like less than 1,000 parts, collaborative with a lot of other people working on it. One of the things we didn't talk about, but this thing operates like a Google Doc. Like right now, we could have 15 people in here simultaneously working on the same document. Everything will update, everything will solve. Yes, shit will jump around on the screen for you when like someone moves a thing in a sketch while you're working on the 3D thing, but like you've seen how OnShape's solver is structured here. It's really good at making everything work together, and I have actually had like 5 people working on the same CAD model at the same time, and it does not blow up. Like it really does work for that collaboration. My honest workflow, like what I teach people in, I hate modeling in Fusion 360. I don't think it's that bad, but I really like OnShape. I design all of my parts in OnShape. I export them to Fusion 360 for things like simulation and CAM. So I teach CAM in Fusion 360, but I still really like modeling in OnShape.
So I'm just thinking about other use cases in a makerspace. I'm thinking like you probably design a lot of other things here, like working projects. If you're going to build something from scratch, you could like model it and then physically build it.
Yep.
That kind of thing.
I can show you, this is printed on the 3D printer here. This is a mount for a rear view camera in my car, and it's on my truck that you can walk past and see it right there. So I like, it's really good for 3D printing. It's really good for CNC. Like those are, I think, the places where it absolutely shines and where I think it is the best tool for it.
Could it import DWG files?
I think so. I've done DXF before. Why do I'm again, import DWG OnShape. Yes.
Because DWG is the original AutoCAD format, isn't it?
Yeah.
It is one of them. And so it's like when it's inserting them into its drawings, and they're like coming in as drawings. So I don't think you can pull a DWG into a sketch and then like use the geometry from that. And that's one of the things you'll find with OnShape. Like OnShape is very pedantic about the way that the geometry is constructed so that all the constraints and everything are obeyed and fits together. It doesn't want you just drop a bunch of points in space in that are free floating and could move around. That messes with its system. And so like it will let you import a lot of things. Like it'll say, hey, look, you can pull in DWG or DXF file, but it's really just gonna show you those. It's not going to let you pull geometry off of those into it in a great way. Like there are other tools for when you get into that. One of the things that I have been experimenting with but have not found a great workflow yet in OnShape, but I'm hoping to do a later class on, is 3D scanning an object and bringing the 3D scan of an object into OnShape and then building parts off of that 3D scan. That's something a lot of people do in Fusion 360. I'm trying to figure out how to do it well in OnShape. If I do, I'll do a class on that. Otherwise, I may have to start teaching some modeling in Fusion 360 as well. OnShape is really good, does have its limits. Sweet. I'm gonna call it there for like official class time. I'll stop the recording. We can turn the lights on, but happy to keep chatting with people and doing other stuff. So thank you, everybody.